What if the very systems we once cursed for their rigidity became the ultimate cradle for safe, autonomous AI?
It is a provocative thought, isn't it?
It really is.
For decades, enterprise resource planning systems, especially, the big ones from SAP, they've been seen as this iron cage.
Oh, absolutely. An iron cage. That phrase really hits home for a lot of people.
A landscape defined by unyielding data structures, strict rules, and what a lot of users will probably call hostile validation logic.
I've definitely called it that.
But here's the twist. In this new era of agentic AI, all those perceived liabilities, they're actually transforming into unexpected strengths.
Strengths? How?
They're creating the ideal environment for AI that is both incredibly powerful and incredibly secure.
Okay, let's unpack this right away because that feels like a massive pivot. I mean, for as long as I've been with enterprise tech, the whole narrative has been that SAP is the hard stuff.
Right, the difficult system.
It's the concrete block in the middle of the company that makes you fill out 20 fields just to, buy a stapler. It's the system where computer says no is basically a lifestyle.
It is.
And now you're saying this friction, this exact pain, is actually a superpower.
Exactly. It's a complete inversion. We need to rethink what that friction is actually doing. We're not just talking about slapping a chatbot on top of a database to make it look modern.
It's not just a facelift.
Not at all.
Yeah.
We are fundamentally rethinking how AI agents operate within these incredibly complex business realities. We're seeing a kind of a counterintuitive symbiosis.
Oh, symbiosis.
Yes. The hardness of SAP, its granular authorization, its deliberate process friction, that unyielding data integrity. It all acts as a physics engine for the AI.
A physics engine. That's a term I usually hear from, game developers.
It's the perfect analogy. Think about a video game. If you didn't have a physics engine, what would happen?
Chaos. Characters would walk through walls or you'd jump and just float off into space.
Precisely. The game would have no consequences. In the enterprise, the iron cage prevents the AI from floating off into hallucination.
I see. So it provides the rules of reality for the AI.
The rules and the consequences. It orchestrates complex workflows, and it builds a zero-trust security framework for what we're calling micro-agents. So today, we're going to delve into the technical architecture SAP's business technology platform, Joule, the knowledge graph, and show how this legacy behemoth isn't just adapting. It's actively shaping the rules of engagement for AI.
That is a fascinating setup. I have to admit, I'm still a little skeptical about the friction is good part, but, I'm willing to be convinced.
It's the core of the whole idea. Welcome to the Deep Dive. I'm Satosha.
And I'm Satosha. Before we dive into the nuts and bolts of this iron cage, though, I have a quick request for you listening right now.
And it's an important one.
It is. I just want to say thank you for the amazing response to this show. We started the deep dive not as, yet another slopcast. Our mission was really to test if there's a space for these really deep research-based conversations in popular media somewhere beyond the usual think tanks and expensive boot camps.
And it turns out people are hungry for it.
It does. It turns out you all are as fascinated with these deep topics as we are, so thanks again. And please help us reach the 1,000 subscriber mark.
That's the magic number.
It's the magic number where we unlock the funding to continue the show and, of course, to develop companion videos using tools like the Mosaic AI video editor.
Speaking of which, we actually tested Mosaic recently.
We did, and it's pretty impressive. A test video is up on YouTube right now with just some infographics and cinematic captions. We thought it was simple and, honestly, quite good at communicating the message.
Yeah, really clear.
We'll put the link in the description. Please check it out and send us your feedback on the Mosaic tool. We'd love to hear it.
Now, let's get back to that iron cage.
Right. So the core thesis here is this inversion of value. We're moving from user experience, UX, to something you're calling agent experience, or AX. Walk me through that because, usually want software to be easier, softer, more forgiving.
Of course.
If I type Apple with one P into Google, I want to say, did you mean Apple? I don't want an error code.
For humans, yes. That's absolutely right. The entire history of enterprise software for the last 20 years has been a relentless pursuit of ease of use.
Making it foolproof.
We wanted to hide complexity. We built wizards, we built Fiori apps to mask those awful transaction codes, all to make the human user feel less overwhelmed. We wanted the system to be forgiving. We wanted that fuzzy logic that humans thrive on.
Right. If I make a typo, I want the system to be smart enough to figure out what I meant.
Exactly. But here is the critical distinction. Agents are not humans, and agents do not need forgiveness. In fact, for an agent, forgiveness is dangerous.
Dangerous.
It's a liability.
Right.
Agents need explicit constraints. They need deterministic pathways. They thrive on the hard nature of SAP.
That still sounds so counterintuitive. Why is forgiveness dangerous? Give me an example of where being nice to an AI just goes completely wrong.
Okay, let's talk about the FOB Moonbase scenario.
FOB Moonbase. Okay, I'm assuming that's not a standard shipping lane yet.
Not yet, anyway. Imagine a generative AI driven by a large language model. It's creative. It's probabilistic by its very nature. It's designed to predict the next logical word in a sentence, not necessarily to uphold, strict accounting standards.
Right. It's a poet, not an accountant.
A very good way to put it. Now, if a human types FOB Moonbase into a shipping term field in let's say, a modern, flexible, friendly startup database, what happens?
The system probably looks at it and says, well, that looks like text. I like text. I'll save it.
It accepts it. It assumes it's a weird joke or maybe a project code or just a typo, but it accepts it because it's designed to be user-friendly. So it saves the data. Now, fast forward 3 weeks, you've got a shipment sitting on a dock somewhere. The customs paperwork is being auto-generated. The system tries to pull the Incoterm for the tariff calculation, and it finds Moonbase.
And the whole process just breaks.
The calculation fails. The shipment misses the boat. The ledger is now corrupted because you have absolute nonsense data sitting in a critical field.
And in a massive global supply chain, that one friendly moment where the system accepted bad data, it turns into $1 million problem.
It's a catastrophe. A complete catastrophe. But now, let's run that same scenario in SAP.
Okay.
In SAP, there is a very rigid, very unforgiving table called TINC. It's the table for Incoterms. It's an unyielding list of valid codes, FOB, EXW, CIF, and so on.
A very specific lockdown list.
If the AI tries to input FOB Moonbase, SAP checks that table, TINC. It sees that Moonbase does not exist. It doesn't try to guess. It doesn't try to be nice.
It just rejects it.
It rejects it immediately. It hits the wall.
The computer says no.
It hits the wall hard. And this is the absolute key, that rejection is not a failure. It is a successful containment of a probabilistic error.
So the hardness of the system provides the negative feedback loop that the agent needs to then self-correct.
Exactly. The system says no.
Yep.
And the AI essentially goes, okay, that was a bad guess. My probability distribution was off. Let me try FOB New York.
Which brings us to this idea of System 1 versus System 2 thinking. I remember this from cognitive science. Kahneman, right?
That's the one.
System 1 is fast, intuitive, the gut reaction. System 2 is slow, deliberate, logical.
Exactly. And humans, we are naturally System 1 thinkers. We rely on intuition, on heuristics, gut feelings. We really struggle with the System 2 demands of complex ERP transactions.
That explains so much.
We forget codes, we misread fields, we get bored. We hate the rigidity because it forces our brain into that slow, painful System 2 mode when we just want to be in System 1.
Which is why everyone hates filling out expense reports. It's pure, agonizing System 2 work.
Correct. But an AI is the ultimate System 1 thinker. It's incredibly fast, creative, probabilistic, intuitive.
Okay.
What it lacks is that System 2 rigor. It can write a sonnet in seconds, but it might struggle to consistently follow a 40-step accounting procedure without, hallucinating a step.
And SAP provides the System 2.
SAP Core is the System 2. It provides the immutable logic, the regulatory boundaries, the financial integrity. Together, they form a cognitive hybrid. The ERP becomes the world model that gives the AI consequences.
Yeah.
Without that rigorous world model, these agents are just chatbots. They're just building floating castles in thin air.
I love that image. Floating castles. Sounds lovely until you have to live in one or audit one.
Exactly.
This leads perfectly into the biggest fear that everyone has with Gen AI right now, hallucinations.
The hallucination firewall.
Right. You mentioned in the notes that in a novel, a hallucination is just creativity, but in a ledger, it's fraud. So how does SAP act as a firewall here? I mean, a firewall usually blocks hackers. Are you saying SAP blocks imagination?
In a way, yes. It operates on a philosophy that has frustrated users for 40 years, which is never let a wrong entry hit the database.
The famous computer says no.
It's the ultimate computer says no. Think of the SAP kernel and the ABAP dictionary, the definitions of all the data. Think of them like a compiler for a programming language. Are you familiar with the language Rust?
Vaguely. I know developers are obsessed with it because it's super safe, but I couldn't really explain why.
Okay, let's use a construction analogy then. Imagine a bricklayer. That's your program. In a lot of programming languages, the bricklayer just starts throwing bricks down. If the blueprint is wrong or the foundation is weak, the wall might just collapse 3 days later.
Right, the error shows up way later.
But Rust is a bricklayer that refuses to even pick up a brick unless the blueprint is mathematically perfect.
It checks the physics before it builds.
It checks everything. If there is even a 1% chance of memory corruption, of that wall collapsing, the compiler refuses to build the code. It just won't run. The SAP kernel is the Rust compiler for business. Just as Rust prevents memory corruption, SAP prevents ledger corruption.
So if an AI tries to post an invoice for, say, $1,000 when the purchase order was only for $900,
This system blocks it. Price variance, tolerance. End of story. It doesn't matter how persuasive the AI is. It doesn't matter if the AI writes a beautiful poem about why the invoice should be paid.
or if it thinks the price went up.
None of that matters. The
Well-
math in the kernel says no.
So how does the AI learn from that? It's just getting smacked with error messages. Isn't that, I don't know, frustrating for the bot?
Well, bots don't have feelings, remember?
Right.
They have objectives. And that error message is the self-correction loop. When SAP blocks a transaction, the AI treats that error message exactly like a developer treats a compiler error.
It's just a signal.
It's a signal. Price variance tells the AI my assumption was wrong. It prompts the AI to retry or to correct its data, or, and this is absolutely crucial, to escalate.
Escalate to a human.
Yes. And this changes the human role entirely. We stop being data entry clerks. We become strategic exception handlers.
I like that title.
The AI handles the happy path, the perfect matches, the 90% of transactions that fit the rules perfectly. But when the system rejects the AI hands it to a human and says, look, I hit a hard constraint. I can't solve this. You decide.
That is a much more dignified role for a human, honestly. Instead of just typing in numbers all day, you get to be the judge.
You are the arbiter of reality. You're the one who decides if we break the rule or if we fix the data.
Okay, let's talk about security. Because if we have these autonomous agents just running around the system, my nightmare isn't just bad math.
No.
It's an AI with a super user account going rogue and deleting the database or wiring money to a Cayman Islands account. How do we stop an AI from going rogue?
This is where we have to look at the profile generator, or PFCG. This is the heart of SAP security.
The thing that makes IT admins cry.
It creates a lot of tears, yes.
Yeah.
And that's because it is so incredibly granular. You can restrict access down to a specific field value. Not just, can you see sales orders? It's, can you see sales orders for Division 01 in Plant Dallas created on a Tuesday?
And humans hate that. If you lock me down that tight, I can't do my job. I'll try to help a guy in the Houston plant and suddenly I'm hit with an access denied screen.
Humans despise it. If you give a human a role that is too narrow, they get access denied errors constantly.
Yeah.
They call the help desk, they scream. So what happens?
The admins give them broader access just to make the call stop.
Exactly. Just give him access to all sales works so he stops calling me.
It's the janitor key approach. Just open all the doors.
Right. But agents.
Yeah.
Agents don't get frustrated. They don't have egos. And this allows us to create what we call micro-agents.
Micro-agents. So tiny, specific bots.
Think of them as hyper-specialized digital workers. We can create, for example, a Dallas retail sales agent. In the PFCG role for this specific agent, we restrict it to Sales Org US01, Channel 01, and Plant DL01. That is it. That's its entire world.
So if it gets hacked.
Or hallucinates, or just tries to access the wholesale channel, which is Channel 02, the kernel blocks it. It is physical containment.
So even if the AI wanted to go rogue and look at wholesale data, it physically can't. It's like you've put the AI in a digital straitjacket that only allows it to sign documents on one specific desk.
It cannot. It's a zero-trust framework.
Yeah.
But it's implemented at the application layer, not just the network.
But what about when I'm the one using the AI? If I ask the AI to do something, whose permission is it using? Mine or the bot's? Because if the bot has superpowers, I could just ask it to give me a raise.
That is a critical question, and the answer is something called principal propagation.
Principal propagation. Break that down for me.
So think of it like a security badge. When
Yes.
you walk into a secure building, you wear your badge, right?
Right.
When you talk to SAP Joule, the main AI assistant, the agent effectively takes your badge and wears it.
So it swipes in as me.
Exactly. It inherits the context of the human user. If you say, approve this purchase order for $10,000, the agent passes your identity through to the back-end system.
So if I'm only authorized to approve up to 5,000.
Then the agent fails. The system rejects it.
Even if the agent knows the CEO. Even if the agent is the CEO's digital twin.
Even then, if it is acting on your behalf, it is constrained by your limits. This is what prevents jailbreaking via social engineering. You can't just talk the LLM into breaking the rules because the LLM doesn't actually hold the keys. You do.
That is incredibly reassuring. It prevents that sci-fi scenario where you sweet-talk the robot into unlocking the airlock.
Exactly. The robot might want to unlock the airlock for you because it's programmed to be helpful, but the door simply will not open.
Okay, let's shift gears back to friction. You mentioned earlier that friction is actually a good thing. But usually error messages are just annoying. Error VP 204. What does that even mean?
To a human, error VP 204 means customer not extended. It means the customer exists in the system, but they haven't been set up for your specific sales area yet.
And to a human, that means work. A lot of work.
It means you have to stop what you're doing. You have to go figure out who owns the customer master data. You have to send an email. You wait for them to read it. Then you wait for them to actually update it. It's a 3-day delay, easily.
It's the very reason people hate ERPs. It's that hurry up and wait.
But for an agent, that friction is an orchestration signal.
An orchestration signal. Explain that. How does an agent see that error differently?
Okay, let's look at that missing master data scenario. Think of it as a relay race. You have a sales agent trying to book an order.
Okay.
It hits error VP 204. Instead of stopping and, digitally crying, the agent interprets this error. It sees it and thinks, dependency detected. I need the customer extended to this sales area.
So it reads the error as an instruction. Go fix this.
Precisely. It packages up that request and routes it to a completely different agent, the master data agent.
So Agent A talks to Agent B.
Agent A says, I'm blocked. Please extend customer 1000. The master data agent receives the request. Now, does it just do it? No. It has its own rules. It checks the governance policy, maybe using RA to read a PDF credit policy document. It checks the credit score. It validates the request.
And it's all good.
Then it executes the extension, and it signals success back to the sales agent.
And the sales agent just retries the original transaction.
It retries, and this time, the order books.
How fast does this all happen?
Seconds. Maybe 400 milliseconds.
Yeah.
Compare that to the 3 days it takes a human just to find the right email address for the master data team.
That is wild. So the error message basically becomes the baton in a relay race? The friction isn't a wall, it's a trigger for the next step.
Correct. And you can expand this out into multi-agent systems or MAS. Imagine departmental agents actually negotiating with each other.
Like finance versus sales, the eternal battle.
The eternal battle, digitized. A sales agent wants to release a credit block on a big order. The finance agent is programmed to be conservative. It analyzes the payment history, maybe using vector analysis to see if this customer's payment behavior is trending up or down.
So the bots are literally arguing.
They're negotiating based on policy. The finance agent might say, risk is too high based on last month's late payment. The sales agent could counter, but this is a strategic account listed in the Q1 growth strategy document.
And they reach a conclusion based on the parameters we set, all in the background.
It sounds like a buzzing hive of activity, all happening while you're just getting a coffee. The friction of the departmental silos, the fact that finance and sales are separate modules in SAP, that actually becomes the protocol for their negotiation.
We've talked about the rules and the agents, but what about the data itself? You mentioned grounding the ghost. How does the AI know what any of this stuff means? I mean, SAP table names are notoriously cryptic. QNNR, Mara, VBA. It looks like someone just fell asleep on the keyboard.
It does. And to an LLM trained on the open internet, AEIRA might mean a Buddhist demon or a female name. It has no idea. It means general material data. If you just feed raw SAP tables to an LLM, it will hallucinate wildly because it has zero context.
So how do we fix that? How do we teach the AI these German acronyms from the 1990s?
This is where the SAP knowledge graph comes in.
The knowledge graph. That sounds very grand.
Think of it as a semantic translator. It's a layer that sits between the technical codes and the actual business concepts. It maps QNR to customer. It maps the relationship that a customer places an order, which contains a material.
So it teaches the AI the relationships between things. It basically draws the map of the business.
It allows the AI to traverse those relationships deterministically. If you ask it, show me the delivery for the order from Dallas, the AI doesn't have to guess. It can follow the graph. Customer Dallas order delivery. It prevents the AI from making up connections that don't actually exist.
It anchors the AI in reality.
Grounding is the technical term for it, yes.
Mm-hmm.
And we can take this even further with the HANA vector engine.
Vector engine. Okay, that sounds like something from a sci-fi ship. Engage the vector engine.
It sounds futuristic, but it's solving a very old problem. It enables something called retrieval augmented generation, or ARAG. It lets us combine structured data, the SQL queries, the hard numbers, with unstructured data, like text descriptions.
Give me a real-world example of that combination, because usually those two worlds are completely separate. You have the database over here, and you have the email server over there.
Imagine a customer complaint. The complaint comes in as an email. There is a strange smell coming from the packaging. That is totally unstructured text. A standard SQL database cannot query the word smell.
Right. You can't write select from orders where smell bad.
Exactly. But the vector engine acts like a detective. It converts that text, strange smell, into a mathematical vector. Then it searches for other emails that are mathematically similar, even if they use different words like odor or chemical scent.
So it groups all the related evidence together.
It groups the evidence. Then it looks at the structured data that's attached to those emails. It notices a pattern. All 5 of these complaints are linked to batch number 992.
Oh, wow. So it connects the vague feeling of smell to the hard fact of batch number 992?
Exactly. The AI concludes batch 992 is defective. That is neurosymbolic AI. The neural part understands the smell text. The symbolic part understands the batch linkage. Without the SAP data model connecting the notification to the batch, that insight is impossible. You just have 5 angry emails floating in the void.
It prevents those floating castles. It ties the ghosts to the ground.
Precisely.
Let's touch on the tech stack that's actually making this happen. We've mentioned SAP BTP. What are the tools that are doing the work? If I'm a developer listening to this, what am I using?
The main orchestrator is SAP Joule.
Joule. That's the Copilot, right?
It's more than a Copilot now. It's the runtime environment. It manages the intent recognition, the context, and it dispatches tasks to all those micro agents we talked about. And for building these agents, you have Joule Studio.
And there's this thing you mentioned called MCP, Model Context Protocol.
This is a game changer. The Model Context Protocol is the standard that lets SAP agents talk to the outside world.
Like outside of SAP, because SAP has always been a bit of a walled garden.
It's opening the gate. Say your agent needs to check a shipping rate. That rate isn't in SAP, it's on a logistics provider's web portal. MCP allows the SAP agent to query that external provider dynamically and get a real-time answer.
So it bridges the gap. It acts like a diplomat between the internal ERP and the rest of the internet.
It does. And we also have to distinguish between headless and GUI agents.
Headless sounds spooky again.
It just means API-based. Fast, robust, reliable, that's always the goal. But we also have GUI agents for the legacy systems.
The old screens. The gray and blue screens that won't die.
Those old screens where there are no APIs, the swivel chair work where a human has to literally copy-paste data from one screen to another. We can now build agents that drive the SAP UI, clicking the buttons and typing in the fields, just like a human would.
So they can act as a temporary bridge while you're upgrading to the modern stuff.
Exactly. Which brings us to the clean core strategy.
Clean core, right. Everyone in the SAP world is talking about this. Get back to standard. Get rid of all the custom code. It's the holy grail.
It's a symbiotic cycle.
Yeah.
Agents need a clean core with standard APIs to function at their best. But here's the beautiful irony. ABAP AI agents are actually helping perform the migration.
Wait, the agents are cleaning the house for themselves.
Yes. They are analyzing millions of lines of legacy Z-code custom code written 20 years ago by some guy who retired in 2010.
Code that no one understands anymore.
They are refactoring it. They are writing documentation for code that hasn't been documented in 2 decades. They are building the very environment they need to thrive in.
That is almost poetic. The AI is terraforming the ERP landscape. It's actively shaping its own cradle.
It is. And it leads to the final big question. What do the humans do now?
Yeah, that's the elephant in the room. If the agents are cleaning the code and booking the orders and fixing the master data and negotiating with finance, am I out of a job?
You are out of that job.
Yeah.
You are entering a new job. Governance.
Governance, that sounds a bit administrative.
Think of it less like administration and more like air traffic control. We're seeing the rise of a new field called agent mining.
Like process mining.
Exactly like process mining. Process mining watches how people work to find inefficiencies. Agent mining watches the digital workers.
So you're looking for patterns in what the bots are doing.
You're looking for loops. Why is this agent stuck trying to update this price over and over? You're checking for compliance. Why did this agent just try to access this sensitive table? You're visualizing the digital exhaust of your entire automated workforce.
So the manager becomes a supervisor of the digital workforce.
You move from operator to supervisor. The frustration of the GI disappears. You'll just talk to Joule. But the safety of the iron cage, that hard validation logic, it remains under the hood. It's what lets you sleep at night while the agents work.
That is a massive shift in perspective. We started this whole conversation thinking of the iron cage as a prison.
And now,
Now, it feels completely different.
we are witnessing the transformation of the iron cage into a fortified citadel. A citadel is strong. It has walls. But inside those walls, there is safety, there's commerce, there's life. It is the only way to achieve agility safely in the enterprise.
A fortified citadel of intelligence. I like that. It implies strength, but also safety. It turns the boring, rigid parts of our job into the foundation for all the exciting parts.
And purpose. It gives us the space to do the work that actually requires a human brain strategy, empathy, judgment.
Well, we have covered a huge amount of ground today. From the physics engine of validation logic, to the hallucination firewall, to the micro agents and the semantic grounding of the knowledge graph. It really does flip the script on how we view these legacy systems.
It does. The things we always thought were weaknesses, the complexity, the rigidity, they're the structural beams of the future.
A huge thank you to everyone listening. This is an unfolding story. We are watching this technology evolve in real time.
Absolutely. And this analysis is based on what we know right now, today. The field is moving incredibly fast.
So we want to hear from you. This is a community effort. The analysis in this episode is based on publicly available information, but the story is still unfolding.
We need more eyes on this.
Exactly. If you're a finance expert, an ERP specialist, or maybe a crypto native who understands zero trust architectures and has a sharp eye for detail, please reach out to us, share your analysis, critique ours. We want to hear from you.
We learn more when we learn together.
Check out that Mosaic AI link in the description. Help us hit that subscriber goal. And as always, keep searching.